Thank you for coming and welcome to this webinar implementing Agentic RAG using Spring AI. My name is Jovkov, like the famous Bulgarian writer Jovkov, but I'm writing on Java. But the truth is that for the last year I only write on Bulgarian, on English, write instructions and confirmations. So in this workshop we will create a RAG system, and we will follow some kind of real life scenario. We will have application, some kind of simulation of real application about store for video production equipment and techniques, and we will add some functionality about RAG functionality about this store. From the beginning, we will create simple RAG, so-called knife RAG, and after that, the RAG will be evolved into Agentic RAG, where the agent, the LLM, will make the decisions from which source of data to gather the data from database, by using REST client API to take the data from different application or from NCP server. And but before starting the real work, I want to make some theoretical base and explain what is RAG, and we will start this. RAG is a technique that combines the power of large language models with some data, some specific data that we have some our data, and in this case the result is more accurate and more relevant. We will use more relevant response by sending the LLM specific our data. If we look here, the standard flow when somebody asks the LLM, the flow is the user writes the prompt. After that, the LLM is thinking, creating the answer, and returning the response. When we have a RAG, the RAG flow is different from the beginning. After the user question, after the query, before sending the prompt to the LLM, we have a RAG model which collects data from our own sources, and since a part of most relevant data that we had query from the query to the prompt, and the prompt is combined with this most relevant data, and the LLM has the power to create format the response, having in mind that our specific data and about the question. Now the RAG process is divided in two separate stages. The first stage is called the ingestion phase. It is the phase where we put and collect our specific data. And the second the second phase is the retrieving our specific data from the RAG with the power of using the LLM. Usually these stages are separated in different logic, and they can be most of the time they can be executed separated by execution. For example, we can load the data. We can load the data once a week, but every minute there can be query about our specific data. Now we will take a look at the first phase. The first phase is ingestion stage. And in the ingestion stage, usually loads the documents with our specific data. For example, these documents can be PDF files, some our own company documentation, some documents, some Microsoft Word documents, text files, or so on. And the usual storage of this our specific data in our knowledge base is in vector database. And in the vector database, there are three processes. The first is chunking the documents. It means that the documents are separated by so-called little fragments of data by different criteria. These criteria depends on the data, and it is chunked by the data is chunked. After that, the data is embedding. Embedding is a process where the data is stored in the vector database as how to say it, mathematical representation in vectors with different I forgot the name, and after that the third process of injection the data in the vector database is indexing. It is preparing the data to be extracted after that. The second stage of the RAG is the real-time query processing stage. This stage has three logical phases: retrieval, augmentation, and generation. How is the right abbreviation? The abbreviation, thank you, of these three phases, logical phases, is RAG. Here the retrieval is when the data is collected from the vector database, from our knowledge base, and the collected data is the most relevant data which we are acquiring and which is stored in this query, this knowledge base. After that, when we have most relevant taken data from our vector database, the next step is to augment the prompt. As I said before, for some minutes, the prompt has more data, the most accurate found data in the retrieval process. Now the prompt is the question, the query, and I will show in the examples. And after that, after this query, there is here is the found result from the knowledge base about our query. After we pass the prompt to the LLM, the last phase is generation. The LLM generates on base of the prompt and the retrieve information from the knowledge base, the LLM creates the response. Here is important which LLM we use. If you use a clever LLM, the response will be better. It is obvious. Now I will mention some method of RAG improvements, and I will mention them fast, and after that we will go to one of the methods, which is Agentic RAG. There can be make improvements of RAG systems. The improvements can be made in the different phases of the logical phases of the RAG process. For example, here is this method is contextual retrieval. It has contextual info about every chunk. If we take a look here in this, when we write every chunk, we can add info. We can use the LLM to write specific info about this chunk, and in this way there will be a metadata which is more useful about this chunk. And this gives us the ability to the retrieval process to be with better results, because we had structured contextual data as a metadata in every different chunk. Another part of the logical phases where we can optimize the RAG functionality is by improving the query. If we look, for example, here, if the query is more optimal, is better, it is obvious that the whole result will be better. So that we can use the LLM to enrich every query, and if the LLM decide to enrich every query, the results will be better. Here are pros and cons about that. The results of the retrieval will be better, but we will make many calls to the LLM. Another way of improving the RAG functionality is creating multi-queries. This method I will use in the project, and you will see how it works. With this method, with the help of LLM, we create several queries according to different data. You will see that we work with our documents in the projects are about different video editing cards for digital video editing, and in the example we will have several queries about every video editing card. Another way of improvement the RAG functionality is by re-ranking. The re-ranking is process after I will show here, after we will have response, after we will have about every query have several, for example, if we have several queries, we will have different responses. And the ranking is a process of checking all the responses, and by additional call to the LLM will decide which of the returned responses has the best answer. We are calling the LLM to decide and to have a better result. And now we are going to our topic, RAG improvement. It is Agentic RAG. Agentic RAG is a way of have an agent which is capable of collecting the data in the here is diagram. The agent collects the data which we query from collecting data from different sources. The agent is capable to make a decision which source to call, and it is capable to make as needed calls to the different sources until it decides that the received result is well done. So with the Agentic RAG in our application, the Agentic RAG will collect data from database, from different application by using REST client API or from MCP server. And now, after this theory basis, we will go to the real project. Now, for the real project, there is user's workshop guide, which is published in the page of the workshop in JPrime. Is there anybody who had downloaded this file and open it? Okay. No, this file is just a second. This file is 12 pages, and here is everything described about the project. Now, to say something about the project. The project is, imagine that we have real-time product stock, which is video production store. Video production store is some kind of simulation of real store, which from here I will show you after a moment. This application is for the availability of some video editing cards. and customers and orders that the customers have made about these cards. And after that project, maybe now first I want to mention why I had choose this domain topic about video production, video editing cards. I have worked as these guys over there as a video production industry between 1995 and 2005 year, and I found that most of the LLMs are not capable to give a good answer about video editing equipment and techniques before 30 years. And so we will check that the LLM is not capable to give an answer, a good answer. It will hallucinate. I will show, and after that we will use our specific knowledge base with users' manual technical specification of some of the cards before 30 years that we used to make video editing, and that's why I choose this domain of the project. I have been working as video editor, sound engineer, and director on air in some of the televisions, Bulgarian televisions, before 30 years, 25. And now I want to show you, first I want to show you the documents of our documents which we will use in our knowledge base. For example, here is Move Machine Pro. It was one of the best techniques from 1994. When I was young. Another is Media Storm. Media 100 in English. Media 100. It was one of top of the video production in some of our televisions. It is interesting that these documents are difficult to find in the internet. There is no data about these techniques, and DPS velocity, mirror motion, that's 30, and some document about different video cards before 30 years. And here is the computer, supercomputer from this time. And now we will take a look at our base application where we will start. This application is Video Production Store. If I start this application, first to start it, I want to mention that there are 5 projects. I will explain and we will go through them after a while. But Video Production Store is the simulation of video store. The specific about this project is that this is there is no Docker container. Just a minute. The specific is that if we take a look take a look at the here in the guide. It is explained about this this project. This project is how to close it. How to close it? I don't know. I will open it. And the specific about this is that this project is a simple REST project with REST API for creating 4 domain objects. These are video editing card, stock availability, customer, and order. And the data is preloaded in the database with Flyway. And the data is stored in the database in this format. There are 4 video cards with their description, the manufacturer, and the price of the card. And stock availability shows which video card, how availability there is of which video card. Here are some customers which are with fictive names: Ivan Ivanov, Peter Petrov, Georgi Georgiev, and so on, with their own data as email, phone, address, and notes. And there have been made an orders about some of the products. The orders describe which customers have buy different video editing cards, and on which date, and some note if there is some note on of the purchase of the order. Now here is the list of API. I will show you the API after a while. What's going on? Yesterday it worked. Why there is such a problem? Aha, this container is running. It's running. This application will be the base of where we will take the data. But why there is another problem? Compose. I found this problem is solved by closing the Docker. Let's open it again. My idea is to create the project. There are seven steps to create the project, and the project to evolve in the next sequential space of development. You will see all the steps after a while, but the first thing is to start the main application. Sorry. It was not planned. I think that everybody had such kind of moments yesterday. It worked. Sorry about that. Oh, it started. I closed the Docker, closed the IntelliJ, reopened them. It started. Okay, we will continue. Here is a Swagger online documentation of this API. It gives us several endpoints about our 4 objects, domain objects: customers, orders, stock availability, video editing cards. For example, we can test some of them. Video editing cards. It shows that there are 4 video editing cards. For example, the customers. Just to show it, and it will take all the customers and so on. They have been created several endpoints about the needed functionality that we will use after a while. After that, we had the first step, had our working application, working video production store, and having in mind that there is data about orders of video editing cards, we will add more information from our documents about describing these video editing cards. And now I'll show you a demo, quick demo for one of the complex test scenarios, just to take your attention, and after that we will start evolve the project. Now I will start the MCP server. I want to mention that I have created a project, Video Production Store Client. This project is a REST client which takes data from our video production store and using the REST way. And this client is used in our MCP server. Our MCP server, I will show after a while, is MCP server which give us the same data available as this video production store that we found in in the Swagger, but MCP server gives the data in a way to be collected from the LLM. And here on the structure of the multimodal projects, in the structure, the most important projects that we will develop after a while are RAG ingestor and RAG retriever. These projects corresponds to the two phases, two main stages or phases of the RAG. The first is ingestion, where we save the data in our vector data store, in our knowledge base, and the second project is RAG retriever. We can retrieve the data from the knowledge base to use it. Here in the project, I will open it. I have created seven steps of the evolving of the project, and the first step. No, after that I had to show you how it works. Just a moment. I have started it. I will start the ingestor application. Only I will show what we want to achieve by developing this project, and after that we will start to take a look at every step of the development. I will start RAG ingestor and RAG retriever projects. I will load the database with the information from these several PDF files, and after that I will retrieve information with some specific questions. Okay, the ingestor is started. After it is started, I will reload the data. We will go in the details after a while. Now I will show you how it works. And after that, we will go in the implementation stages and details. Now it is loading the data in our knowledge base. The data is from these documents, these several documents that I show you about specific video editing cards before 30 years. The data is loaded, and after the data is loaded, we can start the project RAG retriever to take some retrieval of the data. Why anybody can tell me why I have chosen to make different projects, RAG ingestor and RAG retriever? Any suggestions? Okay, I will tell. Because RAG retriever provides functionality only to gather data from our knowledge base or different sources by using the LLM and agent, and this project is stateless, and it can be by creating different projects. It can be make high availability. It can be scaled. It is a good practice for designing the software. But RAG ingestor provides functionality only to fill our knowledge base with data. So it will be not needed to be available every time. It is stateful, and these two projects have different type of functionality, and it is better to be divided. There can be created one project making this functionality, but it is better to be two projects, and for example, RAG retrieval to be scaled. And now we had working application, and there is prepared a document with test plan. Test plan for different scenarios. For example, taking that data only from knowledge base, taking data, trying to taking data which is not stored in our knowledge base, taking data from a simple relational database, from multiple relational database sources, from relational databases and vector database. And I have created this test scenario, and about this test scenario I have created endpoints which can be started, can be executed. Now we have the data from our application, from our video production store application, which holds data for the three domains: video editing cards, customers, stock availability, and orders. And we have data about technical information about these video editing cards. And now I will call some queries, different queries from different types specified here in this document, to see how it is working. First we will ask the LLM. We will try to ask the LLM question about some of this, one of these video editing cards. Only the LLM, not our RAG. Just a second. You will find, I'm asking the question, what is Move Machine Pro? This is video editing card from 1994. And the result is, take a look at the result. The result is something different. For example, the operation system of this card is Windows 10, Windows 10 in 1994. Windows 11, quad-core Intel iPad, Ryzen PET, 34 gigabytes of RAM. These times the RAM was 16 megabytes before 30 years. It is obvious that the LLM is hallucinating, because there are no information about these cards in most of the low-level LLMs. After that, I will show how I will ask the same question, but we will use our RAG. What is Move Machine Pro is the question. And here here the answer is that this is a video editing card IBM 80. It was a specification between years. Being 80 computer. 16 megabytes of RAM is recommended. It shows that it works by reading the data from our documents. Another test is we will ask an relevant question about our data. Where is the pink elephant? And it tells us that, sorry, but I don't have any information about pink elephant. The rack is working properly. Now it will ask a single tool. We will see it after a while. Show me video editing cards, price between 300 and 500 euros. And here the LLM is checking all its sources of data, and he found that in the video editing cards table in a relational database, there is such an information, and it extracts that information. About that, two of the video editing cards are in this price range. And if we look at the, I have created a tracing in the application where I'll measure, how to say it, where we can trace the request and the response. Trace all the process flow. And here, I will sort them, yes. It is the trace of the last query. Here we can see we asked the question about video editing card in a specific price range. The first one is that it is calling this API. After that, it calls the chat client using the LLM, and after that, the chat client is calling this LLM. I will show you after a while. And a specific tool about providing us the information about video editing cards with a specified price range. And after that, the LLM is structuring the answer. Now we will take a look at a more complex scenario. Well, the LLM will use two multiple data sources according to the question. For example, what has customer Ivan Ivanov purchased? And here the LLM found that Ivan Ivanov has made orders about these two video editing cars, and the interesting here is if you look at this trace of the query, it is different. It is different than the other. The trace here shows that now the LLM is calling two different tools. Find customer by name, and by the given name Ivan Ivanov, it finds the customer, which is the customer according which is the record in the database about this customer. And after this customer, it is checking the orders by customer data source, this table, and after that, here we can see that the agent is capable of make decision according to our data and our questions from where to gather the data. Most complex scenario is here when multiple tools, the data can be combined multiple tools and using our knowledge base, vector database. Here the question is, show me the details of customer with ID2 and include the purchase history of this customer and the detailed information about the purchased products. And so it give me the result that the customer with ID2 is Peter Petrov. He had made this order about DPS velocity video editing card. And here is information about DPS velocity taken from our knowledge base, which is in the vector store. And if we take a look in this trace of this query, which is the last one, maybe this one, we can see that here the LLM is making more complex decisions by calling different data sources. First, it checks which is this customer by ID2. This customer. After that, it checks the orders of this customer. It found that the order is DPS velocity video editing card, and after that, it is searching the knowledge base with vector knowledge base, and after that, combine the answer. Okay, this gives us what we will achieve after developing in these 7 steps that I have created. Now I will close the whole project and take a look at every step, what have to be done, and every step will explain how the development process of this Agentic RAG was. How was the development process? You will see it, and I will explain on every step. It depends of the time, but I will explain some specific problems, some specific taken decision, how some problems and some solving of these problems. Now, the initial state of this project is multi-module project with the 5 projects, video production store fully functioning, MCP server and REST client fully functioning, but the RAG retriever and RAG ingester are empty. You will see it. Something specific is that I choose to work with the latest available technologies which are available now, not now, but before a week or two. Spring Boot 4, Java 25 last long-term support release, and Spring AI 2. And I can say, is there anybody who is working with Spring 4? Okay. I can see that Spring 4, there are many problems when you want to use some dependencies, some different dependency from different providers, or in Spring with Spring 4, there are some problems because from the contributors of Spring 4, they have decided to make it more with more granularity, more smallest pieces of dependencies, not just by writing Spring Boot starter and so on, but some of these starters are divided into several inner starters, several pieces of these starters. The purpose of this decision is to be the smallest application with smallest dependencies loaded in the project. So this gives me many problems. But with help of my best friend in work and your two friend, maybe, I solved the problems. Now I will show the two applications. RAG ingestor is empty. It has only setup OpenTelemetry, which provides us the observability, which I show here about system of logging and tracing. It is setup, OpenTelemetry setup here in the project, and the project is empty. And RAG ingestor project, the situation is the same. There is, in the initial stage, there is nothing specific, two empty projects. Now, first, in the development process, the second step will be to write some functionality to be able to call the LLM. And this functionality will help us to see if the LLM is capable of giving some answers about different questions in different domains. How I showed before that the LLM is not capable to give good answers about this video editing course before 13 years. And here, in step 2 of the... Just a second. Here in step 2, I have created functionality that uses Spring AI calling the LLM. And the specific here is that this functionality is in RAG ingestor project, which give us the functionality to ask our system. RAG ingestor is where we ask our system, where we ask our RAG. And here, for example, in RAG ingestor retrieval, I wanted to say retrieval. In our retrieval, we have a controller with endpoint task, and this controller is using facade. Here I have used all the best practice of separating the data in different layers. For example, here is domain layer, web layer. The domain layer is business layer of the application. It is separated in LLM specific logic and observability specific logic. Here the web layer is is separated of controller. For example, here the facade used by this controller. The facade is using the chat client. There we create, with the help of chat client factory, we create a chat client. The creation of chat client is here in this factory, and here is the real client. The real client uses this from the beginning. I have created I have created two types of clients: sync clients and their request response clients, and stream clients. But after a while, I deleted the stream because of the complexity of the project. So there is an interface by calling the prompt, and here is the real LLM client. The LLM client, everywhere in the application there is a logging on every layer, with logging give us useful information what is happening. The client is using created chat client by the factory and calling the prompt. Here is just a simple LLM call. And about that, something specific is about the choosing of LLM, which LLM we will use. Something specific. Every project is runs Docker Compose, and after the starting of the project, they have been creating several containers about that project. Here are configuration properties about the observability, logging, and something interesting is here the choose MML LLM model for chat and model for embedding. I had created four types of configuration, only using Grok model for chat, using and Ulama, for example, for embedding, Grok for chat, OpenAI for embedding, and so on. Interesting here is that, just a second to find it, the LLM model. Interesting here is that the LLM which I use is from Grok, but Grok with Q at the end. Is there anybody using Grok? It is a very good service provided from this company. I will show it. Here you can use different LLMs, different models, which are run in the environment of this company, and there is a free tier which is perfect from such kind of development, such kind of little application. It is perfect. It is free, and I have prepared in the guide that everybody who who wants to run this application can make his own account for 2 minutes, maybe 1-2 minutes, and to use this. This is something like Open Router. Open Router is. I think that you know what is Open Router. It is provided. It is provided service interface for different LLMs. Here you can buy some plan or some quota of LLM calls with tokens, and you can use different where are the models? Different models with something like a gateway for using them. One of the decision was to use Open Router. Here you can use there is a free tier, and you can use free for different limitation of usage of tokens. These models are, as you can see here, one of the best models. But I decided not to use Open Router because it has limitations that are not will not give me the ability to run and to develop and to show the application. The limitation are limit is very low. But the Grok is better about that. This company is hosting free database, free LLMs, something like Ulama. But they had the environment to run some expensive LLMs, not to use, for example, Llama on our computers. And for example, I have bought expensive video card, NVIDIA RTX 5060 Ti for using local LLMs. But after that, I found that the Grok gives me the ability to use better models and free. And this expensive video card is maybe not needed about that. And here are four configuration about combination of LLM for chat and LLM used for embedding. And in the application properties, you can change the profile, and after changing the profile name, it will load different configuration about different LLMs. And here we are using Grok Chat and OpenAI embedding. We use this configuration, and here I use this model. I recommend you. It's a very good model about, according to my experience, it is free by using with Grok. And several times I have reached the limits of this model, token limits for the day, and after that I use this model. This is smallest 70B compared with this bigger 120B, but it gives a good result. And the first stage, the second stage of the project, we had functionality by calling the LLM. After that, we will go to the third stage of the project, where we will create functionality that is using our vector database, which will be in our application, our knowledge base. In this step 3 of the development process, we will add PG vector usage in the project. Here we will extend our RAG in Gesture project, because he is working with loading data in our vector store. And now RAG in Gesture, you can see here that in RAG in Gesture to take a look at the configuration first. The configuration, something new is configuration for the PostgreSQL, configuration for the vector store. Are you familiar that the new versions of Postgre had the ability to provide us a vector database and relational database? And now we are using one DB PG vector, which is PostgreSQL, and extension for vector database. Here, more specific is that our table, which stores the data in the PG vector, is called vector store. It can be called in different names. Another specific is here is specified the dimension of the embedding. Dimension of the embedding is a characteristics of how the data is represented in a mathematical way with vectors in the vector database. How this dimension is bigger, the bigger dimension, the better results after saving the data, embedding the data, indexing the data, and after that searching the data in the vector database. Now something observability logging. Here is about another specific configuration about this project. Is about the searching parameter in vector database. There are two most critical parameters in vector database: top K and similarity threshold. Top K means I don't know if you're familiar with this specific details. To skip it. I don't know. Okay. Top K is a parameter when we are looking and searching some information in vector database. Top K is defining which is the number of top most relevant found results in the database according our search. And top K5 means that the vector database will return five most relevant results according the data, according the set dimension of the embedding when the data is loaded to the database. And this parameter is very tricky and specific about the final result of the RAG after the final result if it if the search will return 5 documents, 2 documents, 2 results about the search inquiry, 2, 5, or 10, for example. It depends on the data. It depends, I will show you after a while with the examples. It depends on the data, how the data is structured. And one thing that I want you to tell you that when working with vector databases or working with RAG, when we want to create RAG functionality, there is no silver bullet to say it. The result depends on the data, how the data is structured, and how these parameters are fine-tuned about the data and the result. Yes. It depends of the data, how the data is chunked. We will look in the code after a while. Algorithm of chunking the data, how the data is, what is the nature of the data. Here, for example, if I open one of the documents in our database, for example, DPS velocity, it is some kind of document, some kind of brochure. Maybe it is only seven pages, and the data format. Here you can see Windows Media Player. You can see that the data is structured in some presentational way. But if I open another document, for example, here in this user's guide of mirror motion DC30, you can see that the nature of the data is very different. It is 70 pages user's guide with technical specification of the video editing card about some specific installation in the computer, how to use it. The nature of the data is different. So, according to the data source, according to our data, we must fine-tune these parameters. There is no one way to, no one right way, no silver bullet. The result will be defined after some проба грешка на български. Trying and error. And that's for why there is specific endpoint in next step 4, where where according to the given question, the question is, for example, we had 4 documents with different data structure, with different data about video editing cards, and the data is not extracted from all the documents. For example, the LLM is decided. It says, "Oh, I'm using knowledge database service for searching and extracting data from our vector database. I found here, for example, 5 or 10 results in one of the documents, and that's enough." And if we extend this parameter, for example, to be 20, here the problem is that we will receive many pieces of data which can be not relevant of the question. There is no one way to do it. Just try according to the data. And if there is no one way with one that the data can be extracted in one with one query, we can use some of this just a second, some of these methods which I mentioned about extracting different data, different nature of data. For example, multi-query RAG, which give us with usage of several different queries according to specific data in the specific documents to receive different results, and after that, on the final stage, the LLM to combine the results according our willingness to have the results. And I wanted to share my experience about this settings parameter. This similarity threshold is a parameter which define how similar is the search result, how is similar question and the data, retrieve data. For example, if we're looking for a car, another similarity will give us bus, will give us bicycle. It is similar. It is moving. Give us moving way of moving, but it is not a car. And these parameters are very important. And here are the parameters, another interesting parameters about the splitting of the information about the chunking process. It is, for example, if I open one of these documents, I will show document here in Move Machine. Here is about the hardware requirements about using this video editing card, and it says that it runs the minimum configuration must be processor CPU 486. This and And now, and another specific requirement is 20 megabytes of RAM, not gigabytes, megabytes, and video card VGA with analog monitor. And when we are saving the data in the database, vector database, the process is splitting the data of parts called chunks. And for example, about this paragraph, it is important how the data will be chunked. For example, it will be a great scenario if this data from here to here is in one chunk. Because after searching in the database, when you write which is the minimal processor CPU requirement for working with this video editing card, it will return this paragraph. But if the chunk is, for example, in this way, selected text, the data will be not extracted in the searching process in a beta format. So the chunking mechanism of storing the data in the vector database is very important. It depends on the data. Sometimes it is, for example, here is this chunk size of tokens. It can be smaller or bigger. It depends on the data. And I had many times playing with changing these parameters, and I found different results. Some good, some bad. I want to say you that when you're storing data in vector database, to have in mind that the chunking is one of the best. One of the most important things in Bulgaria. It is very important because the data will be stored in a good way of extraction after that, and it depends of the data. And here the problem in RAG system is that, as I showed you, that different documents have different data and different structure. And here is very complex and difficult complex process to find a way to be able to extract data in this format, and so on. So many tries and errors. Now, we had in step 3, version 3, we had database, knowledge base functionality working with our vector store. Here the interesting is that in the code we had configuration. It is not important now. Here is the ETL extract, transform, and load process defined. Here in the service, it is one service in the business layer working with the yes.
So you gather all your knowledge in this PDF file.
Mm-hmm. Yes.
Yeah, let's say I have some knowledge in
Mm-hmm.
running in PDF files, so I assemble them
Mm-hmm.
myself or something. And and then this transformer, this whole thing, will put it in the vector database.
Yes.
And the AI will use it from the vector database. Is that the idea?
Yes, the AI will use it, but here we have a functionality only to make some search in the vector database for some testing purposes to see that it is working. And after the next step, the step 4, we will set up the LLM to use the knowledge database as its own advisor. And here we had functionality of load all documents, clear the vector database, load documents, the public method is reload knowledge base and search. The reload database uses this ATL process reader, transformer, and writer. The reader reads the data in some format, DOM format called documents in Spring AI specific. And for example, document here it is class document. It is standard as a DOM representation of the document. This keyboard is I don't use it every day, and the keyboards are replaced. So the data is loaded. After that, the data is loaded in memory as documents. It is transformed. Transformation is splitted the data. With transformation process is divided by split it and enrich the data if it is necessary. Here is the splitting of the document magic. Here this magic happens. And the data from the documents on a final stage is saved to vector database with a specific embedding. And now we have the data in the database, and here is a document reader service which reads the data from vector store, and it had a writer. But the reader reads the data. It reads the data, uses metadata. Metadata I have choose this for information about the file size, file name, and so on, part of the file, to have a metadata in every chunk. It can be useful when we search in our vector store. After that, and in this stage of the project, stage 3, version 3, we had functionality. Here is the test file with the endpoints. We had functionality for reloading the database. I will with executing, but what is happening? Connection refuse. With executing of this endpoint, what is happening? Oh, I haven't started the application. RAG in gesture application. I will load the database. After loaded our knowledge base, after loaded knowledge base in our vector store, I will show that I will show that how to search this information, and after that we will go to the next step, next most interesting step, creating naive RAG, simple RAG. Just a second to start the application. Application is started. I will clean the console. Now, I want to search our vector store with this question: what is Move Machine Pro? And the result is there is no result about this question because the vector store is empty. Yes, it is empty. I will run this endpoint for reload the vector store. It will load here these documents, these 4 documents. After finishing execution of this endpoint, I will call the this question, and we can see that there are answers. And here there are five answers from our vector store. 5 most relevant, depending on this top K5 parameter. Yes, and I will ask question how to drive a car. This information is not in our vector store, and you can see that there is no result. Now stopping this project and go to the most interesting part, simple RAG. I will stop it, and we're going to simple RAG and Agentic RAG. To most interesting main part of the project, but we had to pass this process from here to here. Now the specific usage when we have simple RAG. I will show how the simple RAG looks like. To simple RAG looks in this way. It means that we have a query prompt from the beginning, and after that query, according to the query, we will search in our knowledge base. It is our vector store. We will search in our vector store about the question given in the query, and after that, with the received information, it was, for example, in the last stage of the project, you saw that there are five chunk of text returned, 5 chunk of text, and in the real world, with the real prompt, with the real query, with the real prompt, and with combined with this 5 chunk of results taken from our vector store, everything is combined and passed to the LLM, to the main brain, and the LLM, according to this received data, this received data from here is creating a good answer from good response. And here we will see how it happens with RAG implementation, simple RAG implementation. Here the specific is that we are working in our RAG retrieval project. It gives us the functionality to retrieve the data, where we can ask these questions. Our retrieval project, I will start it. We start it, and when it is starting, I will explain what is happening on the next step. Here, we must make functionality. When we ask the LLM, to use some additional source of data, it is our vector store. And according to the given question in the query and the existing data in our vector store, this data is combined, passed to the LLM, and LLM is creating resulting good format. Here, what is specific? I'll open the just to see if it is started correctly. Yes, it started correctly. I will open the RAG retrieval project. I will open first the configuration to show what are the new add-ons in the configuration. The new add-ons are Spring Data Source. Here is a Spring Data Source. It is configured the LLM to use this source. You will see after a while. Vector configuration. Here the vector is configured with the same dimension as the dimension the data have been saved in our vector store. I had big issues forgotten this with different value. And another observability logging. Here are some configurations specific for the naive RAG or simple RAG. Here is the class path of the prompt. We will take a look at the prompt. It is very important. The prompt here in the RAG, the prompt, how the prompt is sent is are very important about the quality of the result. The first version of the prompt is, for example, what is Move Machine Pro. It is the input prompt, but the prompt which is sent to the RAG in the step when the collected data is sent to the final sent to the LLM. The LLM to be able to produce the result. This prompt is combination of the received data, given good instructions what to do the LLM according to the given received and linked data. You will see after a while, Here is this parameter. These parameters are again existing. They are in a different place, but had the same smysl, meaning. Yes, same meaning. Thank you. Here is a template for a specific data. We will see it after a while, and And here is a multi-query. We will take a look at this after a while. Here to show how it works. We are on version 4, naive RAG. But I have created on every step of the development process to have a different containers, Docker containers, to be able to work in the different stages separately. And here to have data, we must start once again this project RAG in Jester and load the data, because the data is not existing in this container. And after loading the data, we can use our RAG using the LLM with additional source of vector database. Now this project is started. I will reload the database. It is very important to have data in our database. And after that, the database is reloading. We will ask the RAG with this question. And for example, it gives us a good answer about this video editing card taken from the vector database. Now, what is specific in the code? In the code, just a second. In the code is specific that here we had defined sync client. We had defined simple naive chat sync client. This is the interface, and we had simple LLM from the previous step 3. Now we had different implementation of this chat client, which will be naive RAG. And here the chat client from Spring AI is creating different chat client, which here the specific is that this chat client have an advisor. It uses prompt, but it has advisor. Are you familiar what are LLM chat client advisors? Okay. Advisors are some kind of how to explain. Chat client had some bodies which can collect data from different sources, and advisor can be configured from where to take the source. It is to set the chat client which will chat with the LLM from where to take some additional information. And you can add different advisors with give advice of the chat client with different data. source. Mm-hmm.
There are two options. Tools out of this chat.
Yes. Yes. Uh-huh. Good question.
I really don't distinguish.
Mhm. Yes. The tools are tools define some functionality which is described. I will show in the next stage 5. The tools define functionality which is capable to be taken from large language model by its description. Tools is something like, for example, something like an API, but this API endpoint, for example, but this endpoint is described with some text description, and the LLM, according to this description, can decide yes, if to use or not to use one of the available tools.
And this advisor will be called when?
Yes, the advisor will be called always. It is set to the chat client, and always will be called, and always the chat client will process. I had some information. I have this advisor. Let's take a look at his data. I will use it, and if there are several advisors, the LLM chat client will use all of them. But if there are tools, we will see them in the next step of the development. If there are tools, the LLM will check all the tools, check all the provided functionality from these tools described by their description, and we'll take a decision if to use some of these tools, only one tools for yes, we'll take decision if to use this tool. And if we go back here, here we have an advisor which gives additional information. And here the advisor is constructed. If advisor is constructed with this factory, this advisor is created from the first creation of the bin, is cached, and this advisor is using using vector store. Advisor can use different sources of data. This uses vector store. And when we ask the LLM will use every time, in every call will use this advisor, but this advisor goes to the vector store, retrieves the data. Изморих се да говоря. Retrieves the data, and all the collected retrieved data will be combined in the result from the LLM. Now we will take a look at the prompt. One of the things very important is how the prompt is structured. Here the prompt is in naive RAG is more simple, but in the next version, which is Agentic RAG version 5, the prompt, every line of the prompt, if it is different, will the result will be different. I will show here the prompt. This is the prompt for the naive RAG, and it combines two sources: the original query, which is, for example, what do you know about Move Machine Pro? And here it is there is set the context information. It is describing that this is the context. This is the context. This context here is inserted. Here is inserted the retrieve data from the 5 found results from the vector store. This data is inserted here. It is big data according to the results, and after that the prompt has instruction how to react according to some properties. For example, here it is very important, use only answer only the same language, or do not answer in the given context language, only answer in English, for example. I had situations when loading document for video editing card in Italian language. I found such document, and the LLM sometimes gives me the results in Italian, sometimes in English, because it is non-deterministic. It is working non-deterministic, and you're not sure what will be the result, the final result. That's for why there must be written some instructions. Do it only in this way, do it in this way. Do not make, for example, information outside the provided context. For example, when I ask where is the pink elephant, it was the LLM was stopped from here. Don't to try to hallucinate, to try to find some answer clearly. If there is not information content pointed, and the instructions are very important. They depend on the data. They can depend on the data. As I mentioned, that I had a document in Italian, and the results were non-deterministic. So this list of instruction can be enlarged if you want some specific data, and if you want to improve the quality of the result. And now let's go to the most interesting part, agentic AI. Agentic RAG. In the Agentic RAG, the specific is that we will not use advisor as it is used here. Here we used advisor to advise using our vector store. In Agentic RAG, the specific is that the prompt is the same, but here we said the system prompt. System prompt maybe you know that there are different kind of prompts, prompt and system prompt, which holds the system level instruction. You will see it in this version, and in this version we will work with database according to our documents. No, our database from the vector data, video production store. Yes, sorry, but I have tired of speaking. Just a second to load the database. Here is the interesting part when we have Agentic RAG, and the next steps are the Agentic RAG to use HTTP client for to have a distributed system to call the data from another application, and the next step will use MCP server. The next step 7. Just a second to start to load the data and to show what is the specific in development of this stage of the project. In this stage, we are working with Retriever project because ingester was only for loading the data and for searching the data, but RAG Retriever retrieves the data in different ways. Here, a specific is that we had a simple chat client, we had a naive RAG chat client, and here we will have a third variant of chat client. It will be agentic chat client. And that's for a while. There is an interface. There are a factory. Just a second. Rough retrieval application. I have created this part of the application to use in-memory database to show the evolution of the project in the different steps of development in different versions.
Next will be the rest.
Yes, REST calling. Yes, yes, true REST by using the client API, one of this project video production store client. Just a second. Now it is started. I will load the data. Gesture. SRC mine endpoints. Reload. Thank you for being here. the last one. 2007 and 2008, I was associate professor, assistant in Technical University, Sofia, and the situation was the same. When I started the programming classes, whole class, and at the end of the at the end of the class, only several people, but more interesting about learning new something about programming. And now I have loaded data, and the specific here is that here we had specified domain object describing domain object of video production store. The project is evolving, and here are the domain objects. We had LLM response. I will show you after a while. The service, here we had several services. 4 services for working with these domain objects. For example, if we look at this service and we see the methods with public visibility, get video editing card list, document, and now we had a persistence layer. We had here we have a persistence layer with defined interfaces, repositories about every domain object. It is the interface of working with this object, and we had implementation in memory implementation, but in the next version of the project, version 6, we will have another implementation which will be implementation by calling here in the repository. We will call the REST client which will extract data from video production store by REST calling. And now we will take a look at the configuration to see what is new. A good practice is for well-defined structured configuration and well documented. Everything is easy to be found here. Here are the new entries of this configuration parameters about Agentic RAG. System prompt template, where is the file? We will take a look at this. And Agentic RAG, we must take a look at how is chat client is created. Agentic RAG chat client don't use advisor as the naive RAG. It is without advisor, and client and factory, RAG advisor factory. It is creating different advisors, And here for the where are I? Not search request. Not advisor. Agentic RAG. Where was I wanted to show that which by qualifier Agentic chat client. I wanted to show that here is not advisor in the chat client, and the specific is that that the chat client is using tools here, and just a second. Where are the tools? Tools are here, and the tools, as I mentioned, are some provided functionalities which are described. About the tools is very very important to describe what functionality this method provides, to be described in a good way of the LLM to be able to choose the right tool, to choose the right tool, and to pass the parameter if there is a parameter, and to make decision to use and execute this tool. Now, all the logic is move in these tools. These tools are separated according to LLM, how to use the what kind of business logic we had, according to the questions that can be given to our system, and for every different domain object we have different tools. These are different available. Think it as an API which provides some information. It's like a service or like an API which can be called from the model, and it holds service, some kind of service data. For example, here this tool, this method get customer by video card ID will use customer service. You can see that use customer service. It gives, if description gives the opportunity this tool to be called from the LLM, and after that, after calling to the LLM, here is the business logic. It will call the service. Call the service, and the service will create. Will do what is needed. For example, here it will call the repository. Here the repository is from in-memory database, but in the next version, according to the configuration, different beans are created with different repository, and will be called repository by which will extract data from with the help of HTTP REST client. And here the specific is that in Agentic RAG there are no advisors, only tools. And the LLM make decision which tools to call. And we have tools for 4 of our domain objects, and one tool which is capable for searching and gathering information in our vector store. Vector store is additional tool, additional source of data And the interesting here is if we execute, just a second, if we execute some searching query, retrieval, just a second, where is endpoints? Agentic RAG. For example, this query, which customers have purchased the DPS velocity and what are the technical specification of this card. The LLM make decision. We will go to the traces here. I will refresh. Добре. И аз благодаря много. Okay. The technical guys are sending me a message that the time is over. Oh, thank you, thank you guys, thank you everybody.